Welcome to Messy Math Moments Matter, where we explore experiences to help students engage in math more deeply. When we allow opportunities for math to get a little messy, we will see big results. Don't worry about it being perfect. Math class should be perfectly imperfect, just like this video.
Here we are going to be exploring working with improper and mixed fractions. You will need relational rods as your manipulatives, and students should have prior experience using relational rods in your classroom. If not, you might need to include some practice activities or exploratory activities. There's a slideshow that you can use that will walk you through everything that I will be showing you here today. And then you'll need the handouts included in the document. And there's a variety of information in the handouts. You'll have the instructions to walk you through exactly what to say and do. It will include this handout here for students to complete later. Some blank number lines, print as many of these as you need to. The rest of the documents are ones that we have access through NCETM, and their copyright is that you're allowed to use them, adapt them, share them as long as they remain free. So feel free to take what you need from those and make them work for you. The outcomes that we'll be focusing on is grade 5, organizing idea number. Learner outcome number 5, students interpret improper fractions. The understandings that we will be focusing on during this lesson, I've gone ahead and highlighted. They are fractions allow counting and measuring between whole quantities, and improper fractions and mixed numbers that represent the same number are associated with the same point on the number line. I've also highlighted the knowledge and the skills and procedures that connect together to build towards this understanding to reach this learner outcome. Let's go ahead and get started. The first thing I would do with these students is use checkpoint A, which is included in the handouts, where students will go ahead and select all diagrams that represent 3/4 of the whole rectangle or circle that is shaded, and then they're also asked to shade 5/6 of the rectangle. This is just a quick checkpoint to gauge where students are in their understanding of fractions. Experience number 1. Have students place a black rod horizontally in front of themselves, and then create a layer to match the black layer, but it must use exactly 2 rods, and those 2 rods must be the same color. Can students figure out what 2 rods will be placed here that are the same color, and they will create the length of this black layer as well? So as students are working, they will try different ones. Depending on their experience level, they might be able to figure out right away that 2 purple rods will be equal in length to 1 black rod. What is the relationship of 1 purple rod to the black rod? Well, 1 purple rod is one of 2 equal parts needed to make the whole. So we could describe the purple rod as 1/2 of the whole. So let's count by 1/2. Now this is something students should have already have done in previous grades, but as a refresher, we'll go ahead and do that. So we have 1 1/2, 2 1/2, 3 1/2, 4 1/2, 5 1/2, 6 1/2. I would also name that as 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. Now I'm going to go ahead and put this onto my number line. So I'll take this handout here, and I will place my hole below the line, and it's important that this is lined up nicely. Again, in earlier grades, if students have explored this concept with relational rods, they'll have this experience, but it doesn't take long for students to catch up. So there's my 1 hole, there's 1 1/2, 2 1/2, 3 1/2, 4 1/2, 5 1/2, 6 1/2. And 1 baggie should have enough just to fit on there. If they have more, they don't have to worry about tracing them, but they can go ahead and build them. So this vertical line here that I've kind of covered up, but there it is, that's our starting point, so that's our distance of 0, so we would go ahead and label that as 0. Let's go ahead and trace the hole in here. So I'm just going to move these out of the way for now. Make sure it's lined up nicely. The more accurate they are in the lining up, the more accurate their number line will be. And then we'll just go ahead and trace this. And this is our hole, so I will label that as 1. Then I can go ahead and place my halves in there and trace those. So there's 1/2. Well, how many 1/2s do I have now? I have 2 1/2s. How many 1/2s do I have now? I have 3 1/2s. Four 1/2s. Five 1/2s. 6 1/2s. Now it's important when I'm talking about this, especially if students haven't worked with the relational rods or they haven't worked with fractions as length, to talk about the idea that from here to here is 1/2. From here to here is 1. From here to here is 2 1/2s. From here to here is 3 1/2s. From here to here is 4 1/2s. 5 1/2s. 6 1/2s. What's the distance from here to here? Well, that's 1/2. From here to here, that's 1/2. From here to here, that's 3 1/2s. So making sure that they understand that this line here and whatever representation they use here, 2 1/2s or 1, is talking about the distance from 0 to that point. It's not that point, it's the distance to that point. Here's another number line. This is 4 number lines that you can take a look at, and you can use this as a warm-up to kind of go through what we just did, where we are working with 1 hole, 2 holes, 3 holes, halves, 2 1/2s, 3 1/2s, and so on. And this will take them from what we just did, only focusing on halves, and take them to 1/3 and take them to 1/4, so that they can start to engage in that conversation to see the connection between 2 wholes, 4 1/2s, 6 1/3, 8 1/4, and so on. So it's just a little bit of a warm up. So we've named these as how many halves we have from 0, but there's another way that we can name these. So I'm going to put my 1 hole back in here, just to make that a little bit easier to see. And then I'm going to take another 1 hole and place that here. I'm going to remove my purple ones for now. And we'll talk about it in this format. So here I've got my 1/2. That's 1/2. Now I have my 2 1/2s. That was 1 hole. I have 3 1/2s. Now let's rephrase that. Let's rename that as a reference from 1 hole and the quantity of halves. So when I take a look at this, how many holes have I completely filled up? Well, I've completely filled up this hole. This one is not completely filled up. So I've got 1 hole filled up, and I have 1/2 of a hole filled up. So I can write this part here as 1 hole is completely filled up and 1/2 of a hole is filled up. So I can put another one here. How much have I filled up? Well, I filled up 1 hole completely, 2 holes completely. So altogether, I have 2 holes. I want to put this one here I want to figure this one out, but I need to reference it into wholes. So let me add another hole there. So this point here, how many holes do I have? I have one hole, I have two holes, not quite three, so two holes. And how much of this have I filled in? Half of it. So this is, from here to here, is one hole, two holes, half a hole. 2.5 holes. Let's place my third one down here. How many holes have I filled in now? One hole, two holes, three holes. So let's go ahead and remove these to make this a little bit easier to see. Well, what do you notice? From here to here is half. From here to here is one hole, or I could name it 2 halves. From here to here is 3 halves. I could also rename that as 1 whole and 1 half. 4 1/2 or 2 wholes. From there is 5 1/2 or 2 wholes and 1/2 of a whole. From here to here, 6 halves or 3 wholes. Go ahead and take a look at that. What do you notice? What do you wonder? Well, students might be able to see in here that 2 halves and 1 half will give me 3 halves. And 2 halves is 1, and the extra 1/2. So I could write this as, if I wanted to, 2 halves and 1/2 will give me 3 halves. And then I can see my 1 whole very easily and my half very easily. When I take a look at here, 4 1/2, I could see that as 2 1/2 will give me a whole, 2 1/2 will give me a whole. I have my 4 1/2. There's my 1 whole, there's my 1 whole, altogether 2 wholes. Let's take a look at this one. 2 1/2 to make 1 whole, 2 1/2 to make 1 whole. I've used up 4 1/2. I have 5, so I know I have 1 more 1/2. That doesn't make a whole. So 1, 1, that's 2 wholes, plus a half for there. Go ahead and try to figure this one out. So 2 1/2 is 1 whole. 2 1/2 is another whole. That's 4 1/2. I'm not done yet. Plus 2 more halves makes another. So as you are exploring this idea here, you can have students talk about, how will I know if a number is more than 1? So if I said to you 7 halves, how would you know that that is more than 1? Well, because I only need 2 1/2 to make 1, so therefore I have extra 1/2, so therefore it is more than 1. So this is another sheet found in the document, and this one is hidden whole numbers. So students would complete question 1 with a partner, and then we would discuss it as a class. And then students can go ahead and complete question 2 and question 3 together with their partner. And then ask questions like, how can you tell if a fraction is equivalent to a whole number? And what patterns do you see that could be helpful for finding more fractions that are whole numbers? Students can then complete this sheet, which is fractions on a number line, where they're asked to label quarters and eighths and thirds and sixths. So they're going beyond what they've already explored together and just extending their thinking and applying it to new fractions. This cool down is for students to complete. This cool downs are like exit slips, so they complete them on their own at the end of a lesson so that you can see where their understanding is individually. And the most important question to ask yourself is, how does the student's response here dictate where you're going to take them next? So if they understood it or if they're showing misconceptions, both of those should be informing your next steps with that particular student. There are a variety of practice problems in here that students can complete on their own in order to practice the concepts that you have been working on with them. The next sheet is this one. Place the fraction 5 1/2 on each of the number lines. So you'll notice none of these number lines start with 0. It's important to show students number lines that don't start at 0. Otherwise, they get stuck in that habit of always having to start with 0, and that's important when they are adding or subtracting fractions. You'll also notice that this one is 5 to 6, 5 to 7, 5 to 8, and then 4 1/2 to 6 1/2. And this was adapted from Mind the Gap, grade 3 to 5 book, page 148. So this is an opportunity for students to demonstrate excelling thinking, because you haven't asked them yet to show a fraction on a number line that doesn't start at 0. So good opportunity for students. I hope you found this helpful, and I look forward to hearing from you if you have any ideas for more Messy Math Moments Matter videos. See you at the next one.